Hello and welcome to the Year 12 programme. And for our first lesson, what we're going to be looking at today is we're going to be looking at surds. And we're going to, first of all, talk about how it is that we simplify surds. Now, we're going to be learning various laws of surds, which you've probably already met in Year 11. But the first law of surds that we're going to be referring to is root AB is equal to root A times root B. Okay, that's the law of surds that we're going to be utilizing in this first example. Okay, so let's have a look at one of these then. So I'm going to be referring to these questions here off this Solomon worksheet, and let's have a look at a nice straightforward one first of all. Question 4a, and we have got to, it says simplify root 12. Now root 12, I think to myself, okay, what times together to make 12? So that could be 3 and it could be 4. So 3 and 4 like that. And then I can write that as using the laws of surds, root 4 times root 3, using this law of surds here. And then root 4 is 2, so that is 2 root 3. Okay, so 2 root 3 is how I would simplify that one. Let's pick another one at random. Let's perhaps try J. So question 4J. Okay, let's have a look at that one. 4J. Okay, bit of a tricky one here. We've got root 1, 1, 2. So we've got to think of two numbers that multiply together to make that, and let's just try that. So if I go, it would appear that 16 times 7. So 16 times by 7 makes 112. So that is going to be root 16 root 7, and root 16 is 4, so that is 4 root 7. Okay, so that's how we simplify surds that are of that type. Okay, so I highly recommend that you have a practice of some of the ones from question 4 there. Let's have a look now at an expression like, say, in question 5. So in question 5, we got slightly more complex, because what we need to do in question 5 is we need to simplify the surds, and then we need to collect like terms. So I'll do 5C. So 5C, we have got 2 root 8 plus root 72. Well, first of all, root 72, I can think of that as root 36 times 2, which in turn is root 36 times root 2, which is 6 root 2. 2 root 8, now I'm going to think of root 8 as root 4 times 2, which in turn is root 4 root 2 times 2. And then root 4 is 2, so that is 2 times root 2. And 2 times 2 is 4, so that is 4 root 2 plus 6 root 2. So the whole thing there for question 5C comes to 10 root 2. So my answer is 10 root 2. And you'll notice how I've been essentially following the laws of collecting like terms. So you can only add things together if they've got the same root here. So so for example, if I had an expression which was 6 root 5 minus root 3 plus 2 root 5 plus 4 root 3, you can only combine together the ones that have the same number inside the square root. So like I could collect like terms here, so this would be 6 and positive 2, so that would be 8 root 5. So I've dealt with that one, Think about a number line here. I'm at minus 1 and I add 4, so I'm going to end up at plus 3 root 3. And that's an example of how you would simplify them when you've got different types of surds. You can only add them together if you've got the same number inside the square root. Okay. Good. Well, that's like an initial introduction to how the laws of Surds work. Let's have a look now and consider expanding some brackets that have got some Surds in. Okay, so let's look at question 6. Now, in question 6, let's do 6e, because that's a good interesting point in that one. 6e. So in 6e, we have got 3 root 3 minus 4 all squared, like so. Okay, so now there's a really common error here that sometimes students make that I've seen. Students would sometimes think of this. I'm going to put a big cross here and a big cross here to show you that this is not the right approach. 3 root 3 squared minus 4 squared. Now, we cannot do that. That is not what this bracket means, and that would be highly illegal. Okay, some illegal maths right there. What it does in fact mean, if we look at the correct way and show that we're back on track here, when you've got 3 root 3 minus 4 squared, what that actually means is, I'm going to put a big box around that so there's no confusion about the fact that that is wrong. The correct thing is, this means 3 root 3 minus 4 times by 3 root 3 minus 4. Okay, so that's what we need to be expanding. Okay, now I should at this point just, you can expand that however you want. I've got a little thing that I like to use for expanding brackets. I like to use a grid method. Now, you don't have to use a grid method, and I don't always use a grid method. Sometimes I just work this straight out in my head and just write down the terms. But the grid method is useful when it comes to A level, because there's a topic we need to look at called the binomial expansion. And sometimes with the binomial expansion, we do have to multiply together really, really long expressions. And when we have to do that, this approach is easily adaptable to having a much larger thing that we're multiplying together. So first of all, this term is come from 3 root 3 times 3 root 3. So 3 times 3 is 9. So if I kind of like write here what this whole thing is, that is 3 root 3 times by 3 root 3. Now 3 times 3 is 9, and root 3 times root 3 is 3, and 3 times 9 is 27. So that comes to 27 there. Here we have minus 4 times 3 root 3, so that is minus 12 root 3. Here we also have minus 4 times 3 root 3, so that is another minus 12 root 3. And then here in the bottom right hand corner we have minus 4 times minus 4, which is plus 16. So now we collect together our like terms now. So we've got 27 add 16 is 43. And then we've got minus 12 root 3, and take off another minus 12 root 3 is minus 24 root 3. So that one is, that is 6e, and 6e is 43 minus 24 root 3. So that's an example of how we would multiply brackets with Surds. Now, I'm going to stop at that point, and I would highly recommend that you try a little selection of these questions on Surds from this worksheet here, which is a really good worksheet. And in a moment, we're going to move on to talking about how to rationalize denominators. So I'll see you in the next video for a discussion about rationalizing the denominator.